All right, let's talk about shapes, but not in that boring high school geometry class kind of way. I want you to think of quadrilaterals, four-sided shapes, as a giant interconnected family. Each one has its own personality, its own quirks, and a whole lot of family history. So we're going to dive right in and untangle it. To kick things off, let me ask you this. How are a kite and a square even related? I mean, look at them. They couldn't seem more different, right? Well, the answer is pretty cool. It's all in their family tree. And that's exactly what we're about to explore.
You know, every family story has to start somewhere. There's always that one common ancestor, the one that started it all. For our shapes, that ancestor is the most basic, most fundamental four-sided figure you can possibly imagine.
And here it is, the quadrilateral. The rule is super simple. If it's got four sides, four corners or vertices, and four angles, boom, it's in the family. That is the one piece of genetic code that connects every single shape we're going to talk about today.
Okay, so from that one common ancestor, the family tree starts to branch out. And the biggest, most influential branch of all, that's the parallelogram family. This group is defined by one really specific, really powerful trait that gets handed down from parent to child.
So let's meet the head of this branch, the parallelogram itself. You can think of it as the parent, the one whose core features are going to show up in all its kids in some really fascinating ways.
All right, so what makes a parallelogram a parallelogram? Well, here's its DNA, its core traits. First, both pairs of opposite sides are parallel. That's key. They're also the same length. On top of that, opposite angles are equal. And here's a really cool one. The diagonals, the lines that cut across the middle, they slice each other exactly in half. Now keep these traits in mind, because we're going to see them pop up again and again.
Okay, time to meet the first kid. This is the rectangle. Now the rectangle is a loyal child. It inherits all of its parents' traits, but it adds one new, very specific rule for itself. A little bit of a perfectionist, this one. And what's that new rule? The special upgrade is this. All four angles have to be perfect 90-degree right angles. That's it. That one little change, but as you'll see, it has some pretty interesting knock-on effects. So remember, a rectangle is a parallelogram. It's still got the parallel opposite sides, the diagonals still cut each other in half, it's got all that family DNA. But because of those new 90-degree angles, it gets a cool new trick. Its diagonals are now the exact same length. Which makes sense, right?
Now, the parallelogram had another kid, a sibling to the rectangle, called the rhombus. And this one, well, it took the family genes in a totally different direction. The rhombus couldn't care less about right angles. It was obsessed with something else, the sides.
Yeah, the rhombus's special upgrade is that all four of its sides have to be perfectly equal in length. It's all about that side equality. And focusing on that, instead of the angles, gives it its own set of unique powers.
And just like its sibling, the rectangle, the rhombus is still a parallelogram. It's got the parallel opposite sides, the diagonals still bisect each other, all that good stuff. But its new superpower is awesome. Its diagonals now cross at a perfect 90-degree angle. They're perpendicular. Because all the sides are equal, the shape is so balanced that the diagonals just have to cross that way to hold it all together.
So, what do you think happens when you take the best parts of the rectangle and the best parts of the rhombus and you put them together? You get the family's golden child, the overachiever, the grandchild of the parallelogram, the one and only square.
This is what makes the square so special. It's a perfect hybrid. It gets its DNA from both sides of the family. From the rectangle side, it inherits the four right angles and the equal diagonals. And from the rhombus side, it inherits the four equal sides and those perpendicular diagonals. So you see, a square isn't just a square, it's a rectangle and a rhombus all at the same time. It's got the best of both worlds.
Okay, we've spent a lot of time with the parallelogram branch of the family. Let's go meet some of the cousins. This next group, the trapezoids, they play by a much simpler, kind of less restrictive set of rules.
The one and only rule for a trapezoid is this. It has to have exactly one pair of parallel sides. We usually call them the bases. And that phrase, exactly one, is super important. Because think about it. If it had two pairs of parallel sides, what would it be? Yep, it'd be a parallelogram. It belonged to the other family. Now, within the trapezoid family is a more specialized version, the isosceles trapezoid. It's a bit more symmetrical, a bit tidier. It's still got that one pair of parallel bases, but now its other two sides, the legs, are the same length. And check this out. That symmetry gives it something in common with the rectangle. Its diagonals are also the same length. Kind of cool, right? All right, last but not least, let's meet a really unique character in the quadrilateral world, the kite. The kite is like that distant, eccentric cousin that shows up to the family reunion, and you're not quite sure how they're related to anyone because they just play by their own rules.
So what makes a kite a kite? It's all about which sides are equal. For a kite, the equal sides are the ones right next to each other. They're adjacent. That's totally different from a parallelogram, where the equal sides are opposite each other. Just that one little tweak is what gives the kite its classic shape and some of its cool properties, like diagonals that cross at a right angle.
So there you have it. We've met all the key players in the family. We've seen their unique traits. We've seen the DNA they've inherited from their parents. Now, it's time to put it all together and see the entire family tree, all at once.
This brings us right back to the question we started with. How do all these shapes, the square, the kite, the trapezoid, how do they all connect? Well, the secret is to stop thinking of them as a random list of shapes and start seeing them as a hierarchy, a story of inheritance.
And here it is, the big picture. This is how it all fits. A square isn't just a square. It's also a rectangle, and it's also a rhombus. And both rectangles and rhombuses are special types of parallelograms, and every single one of them, at the very top of the tree, is a quadrilateral. It's a beautiful flow of inheritance, where each step down the ladder just adds one more specific rule, creating a more specialized, unique shape.
So the next time you look at a window frame or see a kite flying, maybe you'll see something more than just a shape. You'll see a story. You'll see a family history, a web of inherited traits and unique upgrades that tie all these four-sided figures together into one big, beautiful, and surprisingly logical family.